Hi guys, welcome back to ChemOrgChem. So in this Chemistry 24 into 7 series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem from CSIR 2015. So as per this question, cyclooctadiene react with diporane under 25 degrees Celsius which produce product A. This product A further react with this alkene and followed by this organohalide under palladium catalysis which produce product B. So here there are four options are given. Let's solve together which one is the correct option for this question. So the first step of the reaction is cyclooctadiene react with diborane. So usually this reaction conduct under THF medium. Therefore, when we take THF medium, diborane convert into this borane THF adduct. So this one only the reactive species in this first step of the reaction. So essentially the first step of the reaction is hydroboration reaction. So hydrogen as well as borane going to add the across of this double bond. Hydrogen going to add this carbon and this carbon takes this borane unit. So resulting that produce this corresponding intermediate. So for our convenience, we can redraw this intermediate like that. So now you see this borane contain two hydrogen atom. So definitely this could undergo one more hydroboration reaction with this alkene. So now this reaction undergo by intramolecularly. So this reaction most importantly undergo by regioselective manner. So which means that this hydrogen going to add exactly the sixth carbon. In case of boron going to add fifth carbon. Why this happened like this? So for this you should understand about the transition state of this reaction. So when hydrogen add the sixth carbon and boron add fifth carbon that undergo by perfectly two six-member transition state. So instead of that, now you imagine if hydrogen add fifth carbon and boron add sixth carbon, that makes that one five-membered transition state and one seven-membered transition state. When compared to these two set of transition state, two six-member transition state is mostly stable. Therefore, this hydrogen add sixth carbon. So this fifth carbon takes the remaining boron unit. So resulting that produce this corresponding product. Therefore, this reaction, this product never observed. So the product A is 9-BBN. So this is our product. So in the next step, 9-BBN react with this alkene. So once again, this reaction is hydroboration reaction. So this reaction undergo by regioselective manner. Since now you see this 9-BBN structure, so here this bicyclic ring system heavily sterically hindered system that restrict to add the boron unit in this particular carbon, which means that this reaction undergo by anti-Markovnikov rule. So which makes that this hydrogen as well as this boron unit are the across the double bond by regioselective manner. So now you see this hydrogen ordered this carbon, this boron unit or the terminal carbon. So which produce this corresponding intermediate. Two alkenes are present in this particular substrate. However, hydroboration takes place selectively terminal position because this one is highly sterically hindered when compared to this terminal alkene. So now you should see the steric nature of this 9-BBN also. So let's moving on. So this trialkyl borane in next step react with organoiodide under palladium catalysis. So once you this reaction condition, most of them get sense about this reaction. So this reaction is Suzuki-Miyaura cross-coupling reaction condition. So Suzuki-Miyaura cross-coupling reaction we have already covered in our channel. Their catalytic cycle mechanism as well as various examples. If anyone missed that video, you can find the link in the description box. So under this reaction condition, now you see palladium TPPF and 2 chloride also present in this particular palladium salt. When it interact with triphenyl arsine. Here triphenyl arsine as one of the ligand. So here TPPF is this bidentate phosphine based ligand. So here L means triphenyl arsine. So now this triphenyl arsine replaces these two chlorine atom in this palladium complex, which generate this corresponding palladium complex. Now two ligand dissociate, so resulting that produce palladium 0 as a active catalyst in this reaction. So this palladium 0 in next step undergo oxidative addition with this organoiodide compound. So which produce this corresponding palladium 2 complex. So now you see palladium 0 oxidation state now converted into palladium 2 oxidation state since this oxidative addition. So now this palladium 2 complex undergo by metathesis reaction with cesium carbonate, so resulting that kick of cesium iodide to produce this corresponding complex. In general, metathesis reaction means that so the ligand exchange takes place. So here you can see that this carbonate now coordinate with palladium, so resulting that kick of cesium iodide. So under this metathesis reaction, the oxidation state of the metal never changed. At the same time, trialkyl borane interact with cesium carbonate that produce this corresponding active species. You just remember that Suzuki reaction we need external base in order to activate this boron unit should undergo transmetalation reaction. So now this one is complete. Now this one is ready for transmetalation with this palladium 2 complex to produce this corresponding intermediate along with this byproduct. Now this intermediate palladium complex undergo by reductive elimination to produce this corresponding product along with the generation of palladium 0 catalysis. So here we should note the stereochemistry of alkene geometry. So for that you just see this alkene geometry here iodo group and this ester group both are present to cis to each other. So now you compare the our product alkene geometry. So this alkyl part and this ester part both are present to cis to each other, which means that under this reaction condition, the stereochemistry of alkene geometry doesn't alter. So let's moving to the our question. As per our discussion, among the four answers, the correct answer for this question is option 1. That's it for today's problem. I hope this video has helped you to understand this particular question. If you enjoyed this video, just like it and share it with your friends. And don't forget to subscribe much more content like this. And finally, thanks for watching. Bye bye.